Hello, everyone. My name is Loi Luu. I'm from Kyber network. And the title of the talk is a bit long, but the general idea here is that we are not going to focus on proposing a new solution here, but rather a new perspective when it comes to design a scalable solution or approach for public blockchain. So before I go into the details, this is a quick background about myself and what we do at Kyber. I've been working on doing research, academic research on public blockchain since 2014, and one of the major work is a first peer review sharding protocol for public blockchain that Zilliqa is using. And after that, we created Oyente, the first open source smart contract verifier for that allows the developers to verify the smart contract before they actually deploy it on the main public Ethereum network. Last year, together with other co-founders, we created Kyber network, which facilitate decentralized token swap on Ethereum. And basically what we want to do is we want the decentralized token swap to be used and integrated everywhere, including all the wallets, all the financial protocol, and even in ERC20 token payments. So there's a coming conference, AdCon, I think in May or something, that you can purchase the ticket from any of your ERC20 token that Kyber support. So please watch out for it. We have been integrating with several major financial apps and protocol on Ethereum, like Melonport, Set Protocol, B0X, and there are more to come. So this is not a talk about Kyber, but we really want to share our perspective when it comes to scalable blockchain, because Kyber has been live for more than 6 months, and we have been handling thousands of Ether trade volume per day with thousands of transactions as well. And the main feedback that we receive from our users when it comes to using decentralized application on Ethereum is that first of all, the fees are unpredictable. So the users are willing to pay for more fees if it's more convenient for them, but they are not happy if the fees is $1 today and $10 tomorrow. And certainly there's a long confirmation time, because there's a huge difference when you use Facebook or Twitter or any centralized application than using any decentralized application on Ethereum. So you may have to wait from 15 seconds to something like 20 seconds. And for Kyber perspective, because we have been working and integrating with more than 30 different projects in the space, we really think that scalability should not come at the cost of cross-platform integrations. So far, most of the integration are done fully on-chain. That means only smart contract talk to smart contract. So the moment that we introduce something like new sidechain or new plasma chain, new layer 2, then there's going to be some trust compromise, or there's going to be technical overhead when it comes to integration between different platforms. So that's why we think that the transaction per second metric is not everything, because it's just too broad. It didn't capture the necessary details. What we think is more important is a scalable blockchain should also include low transaction fees, low latencies, and it should allow the users or the developer to run and execute complex transactions, so that we could facilitate more integration between different platforms. And this is what we consider to be much more important to enable real-world use cases, especially all the financial applications that are going to be run on the public blockchain. Now, let's just revisit all the existing, most of the existing scalability approaches that are popularly known today, and see what is missing. So the first line of work is all the new proof-of-stake consensus mechanisms. So here there are, on one hand, we have like, Algorand and Dfinity. They use all the verifiable random function-based proof of stake to randomly, select the leaders to propose the block faster. And on the other hand, we have, all the DPoS and liquid POS protocols that make some certain decentralization trade-off to scale up. And we have like EOS and Tezos other candidates. So this solution definitely offers some level of scalability, but unfortunately, they are not the ultimate solution. The main reason is, all these protocols, they're going to introduce a lot of data to be transferred and stored in the network. And the amount of data grows as the network grows. So this is a developer conference. So can I ask, like, how many of you are running Ethereum public node? Like full node? Okay, I see only 3 hands. Yeah, so, okay, in case you haven't, it's really hard to, run and maintain it and maintain the node for a long time because of, you have to process like huge amount of data already on Ethereum. And with all these, scalable public blockchain that EOS and Tezos are introducing, the amount of data that you need to store and process may increase tens or even hundreds of times. And it's already hard to sync Ethereum from scratch today. That's a sad truth. So eventually, all these protocols, they have to resort to sharding or like layer 2 solution to improve the situation. Otherwise, at the end of the day, only a few nodes are going to be running the entire network, and it's pretty centralized in that way. Now let's talk about sharding. Sharding is pretty nice because it offers scaling without increasing the resources from the existing nodes. So the high-level idea of sharding is that instead of growing one single chain, you just split the network into different smaller network, right? So that each of these smaller network or each of these shards will maintain part of the network. So you can just grow by adding more nodes to the network, creating more shards, without requiring all the existing nodes to introduce more resources, to process more data. So the main limitation of sharding is that there's something called cross-shard communication, because there's a need to communicate between different shards, and that may cancel out all the scaling efficiencies. The main reason is that because the data now is not in one central place. The data is like everywhere now, right? And there's no direct way to get access to data, on different shards. And the end result is that you may have to require, more than one transaction for what is done in one single transaction today on Ethereum. So let me just give you one example, one concrete example. Suppose you want to book the hotel and the flight ticket at the same time. So this is a very well-known and typical example that demonstrates the limitation of sharding. The hotel and the flight ticket system are on different shards, right? And you don't want to book one without the other. So you want to book 2 at the same time. Otherwise, the ticket doesn't make sense for you anymore. So currently, you can do all this activity on Ethereum using one single transaction. You can just have a smart contract to talk to both, the hotel contract and the flight ticket system contract, and everything is done within one single transaction. But in this case of, in this scenario, if you have a sharding Ethereum, you may have to use something like at least 3 transactions. You have to lock up the flight ticket first, and then you book the hotel ticket, and then you, after everything is successful, you release the flight ticket. So all the scalability gain from sharding is canceled out because of this one. And then there's a new line of work coming in the last year called Plasma. And Plasma is very promising because it allows you to move all the transaction to a sidechain, and then you can use something called crypto economic to avoid the cheating, from the validator on the Plasma chain. There are still like several challenges for Plasma, including like data availability, the mass exit. Just imagine there are like millions of users using your Plasma chain, and then something happened to the validator. Now all of a sudden, like millions of people have to go back to the root chain or Ethereum. Currently, there's no like ultimate solution to address all these challenges yet. What people are doing so far is just making more assumption to assume that the problem do not exist, or to scope down the problem. And so that's why we have been seeing like several versions of Plasma, Plasma Cash, Plasma XT, and then there are like more Plasma something coming up. But the main limitation of Plasma is that the most well-known way to scale up a Plasma chain is to add more layers, right? Because you wouldn't expect like someone to run something like Binance or like Upbit on one single Plasma chain, right? Because the amount of data and the computing power that you need like to process that amount of transaction on Upbit or Binance is huge. Not everyone can set up their huge like data center to do that. And in Plasma, what you have to do, you add more layers. And what happens when you add more layers? You introduce more complexity to both security and interoperability. Now the exit game for Plasma with only one single layer is already complicated, right? Now you add more layers. And then we have state channel, which is inspired by the payment channel. The high-level idea here is you can do more transaction off-chain, right? And at the end of the day, you just like do the settlement on-chain, requiring only one or two transactions. So this is very nice. It reduces the amount of transaction on the main chain. But the thing is, it's harder to generalize state channel because, like for example, if you want to support it for complex transactions, you want to support for multiple parties that you don't know like which orders the party are going to participate in the protocol. And state encoding can be hard and can be really large, and submitting the state to the main smart contract may be more expensive than the value at stake. And then we also have the availability assumption for all the parties involved. So that's why state channel is more suitable for like turn-based games or applications in which the order that the players or the parties are going to participate in the protocol. Now, this is the key challenge that we realized after like reviewing all these existing solutions for scalable blockchain. We realized that all these solutions, the key challenge is that like all these solutions, they cannot make assumption on the execution of the applications. So that's why we have to design the protocol as generic as possible so that we can handle all the possible outcomes of the applications. And at the same time, we could see that all the existing solution, they all initially demonstrated with some specific use cases, right? And later on, they realized that it's much harder to generalize the solution. For example, for state channel, we have payment channel, and then for Plasma, we have Plasma Cash. There's no general Plasma yet. So the question that we want to raise is, is it even feasible to build a general scalability solution? Or should we even focus on, looking for a general scalability solution? Now, in order to answer this question, let's revisit the famous scalability trilemma, right? So basically, between all the three properties here, scalability, decentralization, security, you can pick at most two. Now, this trilemma makes sense because it allows people to make some certain trade-off to scale up the blockchain, right? Like, for example, for EOS, they can make the trade-off in decentralization by allowing only 21 nodes to propose a block. And in Plasma, there's some trade-off in like security assumption, like the users, they have to monitor all the validators to prevent fraud and to exit in the timely manner. But what scalability trilemma overlooks is that it ignored or didn't account for some certain trade-off that other people can make as well. For example, we have a very convincing motivation from the real world, right? Let's take a look at the chip design. They can actually design something that scale up really high and achieve high performance by being more focused on what kind of application that they can support. So we have CPU that can do everything, right? And then we have GPU that focus more on parallel, graphic processing applications. And then we have ASIC that just focus on only one single application, and that performs tens or even 1,000 times much better than GPU. So this is the main motivation for the scalability quadrilemma that we propose. So the idea here is that you can make some certain trade-off to scale up your blockchain just by determining what are the applications that you can support, that you want to support. This is because if you know what you want to support, then you can make some certain assumption on the execution of the applications. And you can tailor specific solution that leverage this assumption and scale up accordingly. So for example, we can do something interesting with sharding here. And this is what we call Project GOMOS. We know that many applications can benefit greatly from sharding. For example, all the applications that have multiple components, and each of them do not talk to each other so frequent, right? And you can design some simple sharding strategy, you put each component in a separate shard, right? And then all the cross-shard communication is much less compared to the intra-shard communication. And this approach can be used for either layer 1 or layer 2 solutions. So this is a simple high-level design. I'm not gonna go into the details, but basically you put each of the component of your system in one of the shard, and then there's one main shard that have coordinate with all the shard in your system. So we can do something sharded decentralized change. We can have one trading pair corresponding to one local shard, and then the main shard can facilitate the transfer of the base currency. In this case, this is Ether or Bitcoin. And you can also use this architecture for something called decentralized sharing economy, right? Something like Origin protocol, in which you can have each of the shard represent or takes care of one graphical location. So if you have decentralized Uber, right? You can just have one shard taking care of Korea and one shard taking care of Singapore and something like that. Yeah, so to conclude, we we want to raise the question about scalability, scaling general purpose blockchains, because we think that it might not be feasible to do so, and we encourage the developers to start looking for scalability solutions that work better for their purposes, instead of trying to build a platform that works for everything. And we just started the project Gomos at Kyber, and we love to welcome collaborators. So please reach out to us or join our technical group, our Telegram developer group. We would love to talk to you more there. Thank you. I think I still have a couple of minutes to take questions.
Few questions.
Yeah.
혹시 질문 있으십니까?
Hey, Virtue.
Hello. I want to know if you could compare and contrast Kyber network versus the Uniswap exchange. I actually don't know the differences, so I'm hoping you would tell me.
So I think Uniswap is quite similar to like Bancor, right? In a sense that they have they use what we call automated market making mechanism. I think that mechanism works well for like illiquid tokens, right? But like for liquid tokens, you really need like high like much more inventory to support like reasonable spread. Yeah. So in Kyber we do support like both like automated market making and then like manual market making. Like we have like someone behind the scenes to actually market make for the thing, for the pair efficiently. Yeah. Thanks.
또 혹시 질문? 아니. 또 질문 있으시면 손 들어주세요. Any questions? No?
Thank you.
네, 감사합니다. 박수 부탁드립니다.
Yep.